An orchid seed weighs approximately 3.2 times 10 to the power of negative 8 ounces. Calculate the number of seeds in a 2-ounce package, giving your answer in scientific notation or standard form. And so in order to answer this question, in order to determine the number of seeds in a 2-ounce package, we have to divide. Now, what are we going to divide? Well, we're going to take 2 and divide it by 3.2 times 10 to the power of negative 8. And so that's what we have here. 2 divided by 3.2 times 10 to the power of negative 8. Now, what we're going to do is we're going to group together. So we have this 2 and 3.2, so we group them together. And so we have 2 divided by 3.2, and we have this gonna be 1 over 10 to the power of negative 8. And so we do that because we want to deal with this number 2 and the decimal number 3.2, right? So we want to deal with 2 and the decimal number 3.2 by itself. So that's why we group it. And then afterwards, we're going to deal with the term that has the base 10, all right? And so what we have here is 2 divided by 3.2, and 2 divided by 3.2 is definitely 0.625. That's what 2 divided by 3.2 is. 2 divided by 3.2 is definitely 0.625. Next, we have 1 over 10 to the power of negative 8. Now there's a rule, right? And the rule states that if we have 1 over a to the power of n, right, that equals to a to the power of negative n. Okay, that's the rule, okay? And so we have the same thing. So we have 1 over 10 to the power of negative 8. And so based on the rule, this is going to be equal to 10, right, which is a 10 to the power of what? Negative n. But notice that we have negative 8 at the bottom. And so it's going to be negative, open bracket, negative 8. Because our n is already negative. And so what we have here is, again, 1 divided by a to the power of n is equal to a to the power of negative n. So what that means is if you have 1 divided by a base, which is a to the raised to the power of an exponent, what you're going to do is you're going to take that base and you're going to raise it to the power of negative that exponent. But the thing is that in this case, we already have negative 8, all right? And so when we put 10, we have to put 10 to the power of negative this negative 8, all right? And so that's why we have here 10 to the power of negative 8. Now a negative times a negative is definitely a positive. So what we actually have is positive 8. And so we have 0.625 times 10 to the power of positive 8. And what we have here is, this is not in scientific notation yet because this number right here is 0.625, but this number has to be bigger because in order for this expression to be in scientific notation, this number has to be any real number from 1 to 10, but not including 10. And so notice that the decimal point is right here, but we're going to move it over once to the right. And so that means that we have 6.25 times 10 to the power of negative 1. Now we have 10 to the power of negative 1 because we moved it over once to the right. And that's why we have the negative 1 there. Now we have 10 to the power of negative 1 multiplied by 10 to the power of 8. And so we have two terms that have the same base, all right? And we're multiplying them. And so we have to add the powers. And so what we have here is 6.25 multiplied by 10 to the power of negative 1 plus 8. And negative 1 plus 8 is definitely positive 7. And so we have 6.25 multiplied by 10 to the power of 7. And that is the correct answer. And this answer is definitely in scientific notation. And that's the answer to this question.